Hello again, everyone. This is Amir McKean, electrical engineer, author, publisher, and founder of AIC Publications and the Black Stemporium podcast, your number one source for science, technology, engineering, and math, starting your own publishing business, building generational wealth, economic empowerment for the Black community. Energy is not created or destroyed, but transformed from one state to another as a result of an action upon particles. Contemporary science has defined energy as the ability to do work. Physics has defined work as the force applied on an article or object in both magnitude and direction. Depending upon the particles at work, the resultant energies can be potential, kinetic, mechanical, thermal, that means temperature, hydro or water, and many others. In order for us to put the energy to applicable use, we can define it in both mathematical representation and word. Each energy form has different forces that impact its function. The particular form of energy we will focus on here is electrical energy. This is all part of what is being called science, technology, engineering, and math, or STEM. Now, let's break down all of these acronyms. Science, let's define this first. Science is a creative discovery that begins with creative questions in the mind. Technology is using the understanding of the resources in the world around us to generate applicable solutions for problems that are common to all in human society. Engineering is the use of critical thinking skills to determine which application is the most accurate and best fit for the solution. Mathematics is merely the universal language that connects all three terms together. To not allow ourselves to be intimidated by this, you must know that STEM as a thing or a concept can be implemented, executed, or performed through this simple acronym that I've developed. It's called creativity, understanding, determining, and universality, or kudu. What this means is we take the action in all of the definitions that I just gave you in science, which is to use the creative thinking and the creative skills that are in your mind to ask questions about why things exist in the universe around you. Then we have to understand the technology by using the resources in the world to generate applicable solutions. And then we use our critical thinking skills, which they don't teach in traditional education, which is the engineering aspect, to determine which application is the most accurate. And then the mathematics is nothing more than the language. And just like a language, we'll teach you how to use and understand that language. Now, all too often, traditional education approaches science, technology, and engineering in a very disconnected and disjointed way. When taught this way, the student is forced to separate the different concepts, explaining how the universe exists and functions as one big machine. In other words, understanding how the interconnectivity and interdependence of all particles are with one another, it's not stressed enough as it is necessary, and therefore the student isn't able to connect with the material. This especially leaves behind the Black African American student. A 2022 study confirmed that 67% of Blacks surveyed view engineering as a field that is unwelcoming to them. 64% of Black African Americans surveyed also believe that the current Black engineers that exist, myself being one of them, have already topped out in the success they're going to have in their various fields. Consequently, because of these parameters, the natural tendency to ask relevant questions such as, what is this used for? Or how is this helpful to me? Never get answered in the young questioning mind. Here's an example. When science courses are taught, Educators always start with a mathematical formula, and students are told to burn this formula into their mind in the manner of this problem, so on and so forth. The student, automatically not having that interconnectivity, gets bored and unable to relate. Rarely are the students given examples that are relevant to themselves, leaving them disincentivized to place themselves in the center of why, how, and when this subject matter will impact them. We will explore all of this and more as we proceed with our content development. We'll unpack and extrapolate on many of these data points so that you can understand the why behind all of this. Because once we understand why, we can deconstruct it and build upon a plan of execution for success in spite of the troubling data I just gave you. Now, thousands of years ago, in the cradle of civilization, man in Africa began to realize that crystals found in the earth, made of different materials, when heated or cooled, could create amounts of what would later be known to the world as electricity. This is called the pyro effect, and it still exists today. It's because of science such as this that we've come to understand and benefit from other forms of energy. We can literally trace light and heat that we get today as a simple byproduct of the pyro effect in ancient history. Electricity is literally a flow of electrons. This is critical and key to understand because in their raw state, electrons, when they move, they're not organized, but they're very chaotic, and they'll move anywhere the environment or the space around them allows. When we begin to control the how, the where, when they move, and through what material they move, that's when we call that the study of electricity. Oftentimes, you will hear the terms electrical engineer or electronics engineer used. Sometimes even I'm asked the question about when to use electrical versus electronics. Let's explain. Now, when we study electricity, we're also using physics and the mathematics to be able to predict how the flow of electrons will impact our design, whether that design be a cell phone, a television, or our own circuit that we build, how we can manipulate the flow of electrons to control, let's say, a widget. And a widget could be anything that we're going to build, like an electric car or a video game that can do what we want when we want. Once we start using electrons to build or construct widgets such as these, we can say we're actively using electricity or electronics, using physics and mathematics to understand how the widgets can be constructed and predict how the widgets will behave under certain conditions becomes the electrical analysis. Now, when discussing electricity, we're talking of a high quantity of electrons, and we call a certain number of electrons a charge. As a charge, 6.625 billion electrons is called a coulomb. This means that in the study of electricity, the unit for electric charge is the coulomb. We use this because in reality, it's very difficult to count electrons one by one. So the coulomb creates a uniform standard for charge by counting a designated number of electrons. Now, when we understand the term of electronics, when we're discussing it, we're taking the electrical analysis and adding to it what are called active devices. An active device is a device whose electrical behavior only occurs when the power is applied to it, or simply put, when it's plugged into an outlet. Active devices would be items such as transistors, operational amplifiers, voltage regulators, and many others. A passive device is a device whose electrical behavior remains the same if power is not applied to it, or very simply, when it's not plugged into an outlet. Passive devices would include resistors, capacitors, inductors, and others. We will cover all of this in the Black Stemporium podcast and the AIC Publications 10-Minute Engineering Program. If you've enjoyed our content and want more of it, I need you to do 3 things to help us reach more of our audience. First, go to our website using the link that you see on your screen and subscribe to the AIC Publications newsletter. You will get weekly emails whenever we release tutorials, podcasts, episodes, new books, contest giveaways, and more. If you do this, you'll be able to get a free book as well. Second, subscribe to the current platform that you're watching or listening to me right now. Third, share our content with at least 3 of your friends using the hashtag AIC Publications and give us a link. Thanks in advance for helping us demystify the math, simplify the science. We want all of our community members to attain the knowledge, innovate for success, and command your future. Till next time, all the best. Peace.